Subscribe the channel and press the bell icon for latest updates.
Bismillahirrahmanirrahim. Today we will study about physics, class 9, chapter number 4 and lecture number 1. The name of the chapter and our today's topic is turning effect of forces, which is on page number 100 and 101 on your book. The date is 9 April 2020. So our first lecture is about this chapter overview, that what does turning effect of forces means. So turning effect of forces basically means rotational effects produced by forces when force helps something to rotate. As we already know, force is an agent that produces both linear and rotational effects. It means when something is moving in a straight line, that's called linear, and when something rotates around its own axis, that is rotational effects. So here we will discuss mostly rotational effects because we have studied the linear effects of forces in the previous chapter, which is chapter number 3. Now our first topic of this chapter is force diagrams. So to study the effect of forces on any object, we can apply the skill of drawing force diagrams. It means that we will uh, discuss the force exerted on a body in terms of diagrams. As we have studied that force is a vector, so it can be represented by an arrow. Just like in chapter number 2 we have studied that forces or vectors can be represented by arrows, the graphical representation of vectors. In force diagram, the dots show the point at which the force is applied. It means whenever you see a dot, it means that at this point the force is applied. The magnitude and direction of force is represented by an arrow. It means if the arrow size is greater, it means greater force is applied, and if it is smaller, then we can say that smaller force is applied, and the arrowhead will show the direction in which the force is applied. So our first example, which is in your book, is actually a book lying on a table, and where two forces are exerted. One is the weight of the book and the other is the normal or the perpendicular force which is exerted by the table on this book. So here we will describe forces exerted on a book lying on a table in terms of force diagrams. There are two forces exerted on the book. One is weight acting downward and second one is force exerted by a table on the book in the upward direction. As we can see that the two arrows are equal in size and opposite in direction. Now this arrow, the first one, the normal force, and the direction of the weight, the arrow of the weight, both are equal. So both cancel each other. Hence the net force on the book is 0 and therefore the book is at rest. That means when something is falling only under the influence of gravity and there is no more force is involved. So here we will describe the force diagram of a free falling book. It means that this book is only falling because of gravity. There is no support for this book, and actually this book is falling. Why is the book falling? That's because of the weight of the book. So if we neglect the air resistance, the only thing that brings the book downward is gravity, and therefore it's called free fall. It's called free fall motion. The only force exerted on a book here is weight, which is downward, and the book is unbalanced, and that's why it falls. It means there is no other force involved here so that it may balance this weight. So this is actually the vector diagram or the force diagram of this free falling book. Now we will study about the parallel forces. So actually if the direction of forces is either parallel or anti-parallel, it means if there are two forces or two or more forces, and they are even if they are parallel or anti-parallel, they are termed as parallel forces. Both of them are termed as parallel forces. Now there are further two types. One is like parallel forces and the other is unlike parallel forces. So if the direction of forces is parallel to each other, they are called like parallel forces, and if the direction of forces are opposite to each other, then they are called unlike parallel forces. The first one we will discuss the like parallel forces. So actually the like parallel forces produce linear effect. These two forces are in same direction, so both of them are like parallel forces, and they move something only in a single direction. Therefore this type of force produces the linear effect. When we example is when we lift a box with double support, we are actually applying lag parallel force. Suppose you have a box and that have two supports, and you are lifting it up with two hands. So actually this type of forces is actually lag parallel forces. Such forces support each other. It means they add up with each other. In the given diagram, F1 is smaller than F2. You can see that this arrow is small and this arrow is big. So F1 is smaller and F2 is bigger one. Now, unlike parallel forces usually produce rotational effect if the point of action is not the same. Here there are two forces, the F1 is downward and the F2 is upward. The point of action here is this one and the point of action for F1 is this one. So both are different from each other, hence it will produce rotational effect. When we rotate a steering, we apply two opposite forces on each hand. The direction of both forces is opposite to each other. Such forces oppose each other, and in the given diagram F1 is smaller and F2 is larger. Thanks for your attention.